during the memory organizations of the 8051 or NCS 51 microcontroller, that means what are the partitioning of memory, different memory, that is program memory as well as the data memory. Anyway, the reset is an active high, that is active high logic. When the at this pin number 9 of the 8051, the logic levels at the pin number 9 will go high logic level, so resetting will occur. But according to the reset circuit, typical reset circuit, a positive going reset pulse should be applied at the reset input. So that's why that is a reset circuit. That means the capacitor is charged via the resistance. Resistance typical value is 10K of the order. That depends on the durations of the reset timing. How the active high pulse must exist so that resetting will occur. So there are definite amount of the finite positive pulse which must be generated at this pin 9. Now, that means when the capacitor will charge, so the current, the charging current will flow by this resistance. At the initial time, at the time 0 time, the maximum current will flow. So the potential drop across this resistance with respect to ground will be high. As the capacitor will be charged more and more, so the charging current exponentially falls or decreases, so that the potential difference at this pin will also decrease. That means there will be a reset pulse. So how the reset pulse will look? So this will be the reset pulse. That means at the 0 time, the maximum potential drop will occur. As the time goes on, the voltage levels will fall. So that means the duration of the reset pulse is of this amount. So there must be a finite duration. If the reset pulse, the duration of the reset pulse is less than the prescribed time limit, then the proper resetting will not occur. So that is possible. That is true or valid for every microcontroller of the microprocessor. So proper reset signal must be applied across the reset pin. And this type of resetting, that is when the microprocessor is energized by a DC signal, this type of reset signal is called the power on reset signal. That means when it is powered up, the reset pulse will occur. It will not at the fixed voltage level, that is high level, permanently. So this is the it is called the power on reset. So this is the power on reset circuit. Now, when the microprocessor is required to be reset at any time asynchronously, then what to be done? A push button must be connected in parallel across the capacitor. So if this push button is pressed on, what will happen? The potential difference across the capacitor will be zero. And here also the potential difference will be zero. Then the push button should not be pressed on permanently, but there must be a make break action. So the push button should be temporarily pressed and it will be released. So which in effect, again the reset pulse will be produced upon pressing this push button. So this type of resetting action is called the manual reset. Closing the switch momentarily will make the reset RST high. But power on reset is that means this is occur when the microprocessor is powered up every time. So these are two types of the resetting actions is required. So upon reset, what will be done? Program counter is loaded with port 0 hex, but the content of the on-chip RAM is not affected. Now, soon I will explain what is meant by the on-chip RAM as well as what is meant by the program counter. So every microprocessor or the sequential machine, that is microcontroller, there must be a program counter. And the program counter will keep tracks on the current address from which the instruction will be fetched by the microprocessor or CPU. So in the initial lecture, I have described the internal architecture of the 8051, which consists of program counter, a 14-bit program counter, because the leading 2 bits will be Anyway, I have to show the proper diagram. This would be available, this block. So these are the consequences of the power on reset. As well as after manual reset, occurrence of the manual reset, this will be the content. So that is the speciality. Now, how the speed of the processor will depend on the oscillator circuit or the clock circuit. 8051 will operate on typically 12 megahertz, 11.059 megahertz. To even 30 megahertz, which is available. So these are the typical oscillator circuit which should be connected. The crystal of the frequency have to be connected by the two parallel capacitor. Sometimes there is another principle without any piezoelectric crystal using, which is called the ceramic resonator. Nowadays, ceramic resonator is a oscillator circuit which are available in the integrated circuit form. So that is also available. The principle of the ceramic resonator is different. But the oscillator, typical oscillator uses that is a piezoelectric crystal and the two capacitors C1, C2 value. And the value of the T of C1, C2 will lie between 20 picofarad to 40 picofarad. And this type of crystal oscillator will be internally wave shaped by 8051. As well as in place of the typical piezoelectric crystal oscillator circuit, an external oscillator circuit can be connected. So the two pins should be connected directly, one from this and another from a inverted logic. That means if it is high, it will be low. So this is called the TTL oscillator circuit. Otherwise, this type of circuit is called the crystal oscillator circuit. But it is preferably recommended that the crystal oscillator circuit, because the tolerance of the piezoelectric crystal is very, very low. The frequency will be almost constant. Otherwise, if we use the logic gate and the other oscillator circuit, the tolerance may vary. So that depends on the temperature variations and the electronic drift. So this is the typical oscillator circuit for a 80. So the basic frequency, the base frequency is approximately 12 megahertz. Exact value is 11.059 megahertz. Okay, but if the clock, that means the clock should be very, very stable. Otherwise, there will be a variable execution for a microcontroller. So that should be remembered. Now, the very important part of the 8051, that means memory organizations or internal memory organization, because as we know, the 8051 consists of the program memory as well as the data memory. The data memory is of RAM, read-write memory. There must be a provision for interfacing an external memory of the volume or size address space 64 kilobyte maximum. But internally, the program memory is of 4 kilo. That is called the embedded memory. So the internal program memory is a 4 kilobyte size. But what is the size of the data memory, random data memory? That is only 256 bytes, very small. So this is the architecture of the internal architecture of the data memory, which are partitioned for user accessibility, that is only 128 bytes. Again, for some part, some volume, which are not user accessible, but it is used by the internal blocks of the 8051. What are the internal blocks? The name of the internal blocks is SFR registers, the special function registers. Okay, I will discuss about what is meant by the special function register. Plus 128 byte 3 location, so which combines 256 bytes. But external data memory, this is the actual view. So how the program memory can be partitioned into two parts. The total external memory size is 64 kilobytes, and the internal program memory size is limited to 4 kilobytes. So the rest 64 kilobytes is expandable. That means when we interface the external memory and the internal memory in combination, so the external memory size becomes 60 kilobytes, whereas the internal program memory size is 4 kilobytes. Otherwise, if we interface the total 64 kilobytes program memory, so this internal program memory will be ineffective. So this part, the diagram for program memory, where the microcontroller application code or instruction compile code will reside, and this diagram is meant for the data memory. So this data memory again can be partitioned, but generally internal data memories are generally used for application programs and usage by the internal GP registers. So these are the address 00 location to 007F are the address range for the 128 bytes data memory, whereas 0080 to 00F8, the bottom and the top address, this address range is dedicated to the special function registers which cannot be accessed by the user program. User can access only this part. So this is the description of how the data memory can be accessed. It should be remembered, that means the architectures of the microcontroller follows Princeton architecture. Now, what is Princeton architecture? That I have discussed already. না চা খাবো ওই যে ধোকা দেখেছি টেবিলে না শুধু ধোকা এমনি ধোকা যেমন কেটে কেটে So this type of architecture is followed by the microcontroller called the Princeton and Harvard architecture. Otherwise, the normal that means normally the any microprocessor can follow this architecture, which is called the von Neumann architecture. In von Neumann architecture, only from the processor CPU, data, address, and the control bus are coming out. But in Harvard architecture, there are two sets of this bus. Both are of address data control, which are connected to the program memory. Another is connected to the data memory or register space. So that in no way the data will overlap to the program memory. That is the specialty or comparisons of the von Neumann and the normal architecture. Harvard architecture in storing speed that's more time consuming, but this can be tackled. But von Neumann architecture, higher speed, that's less time consuming. In Harvard architecture, separate memories for code and the data. In von Neumann architecture, only single memory block to be shared by both code and the data. Processor needs to fetch code in a separate clock cycles and the data in another clock cycle, so that it requires two clock cycles. Single clock cycles is sufficient for Harvard architecture, as separate buses are used to access data and the code. So that's why as the microcontroller follows the Harvard architecture, so that's why the data memory are separate to the program memory. So these are the specialty of the memory architecture. Now, what is mean by the SFR? What is the size of the SFR? Special function registers, 128 to 255 bytes. Now, again, what is SFR? And what is GP registers? There is no special or separate registers in case of a 8051. Unlike in the case of the 8051. 8051 has a 6 set of the registers. Each of 8 byte, it can be used in 16 2-byte pair. But here, there is a byte registers, 7 number of the byte registers, which are designated R0 to R7. But these registers occupy a particular area of the data memory having fixed address. That means in case of a 8051 architecture, the registers falls upon the data memory. That means this part of this memory, whose address is 0 hex to 32 decimal, 0 to 32. So 4 in array of the memory space are utilized for the 8 number of the GP register in 4 banks. That means this bank 0 has 8 number of the registers. So their address is 0 to 7. Similarly, bank 1 contains same 8 number of the register R0 to R7, whose address fall in the range 8 to 15. Similarly, for bank 2, 8 number of the GP register are available, whose address range falls from the 16 to 23. And for bank 3, 8 number of the registers are available, whose address in the data memory are available from 24 to 30. So 32 bytes are reserved for storing the data to how much GP registers separately? 4 into 8. That is, in that case, the number of GP registers in case of a 8051 is much more. The net value is 32 bytes. But by a bank switching technique used by the instruction, special type of instruction, 32 bytes can be saved to this part of the internal data memory. So that is the specialty of GP registers, general purpose registers in 8051. As such, there is no 32 byte separate registers, but these 32 byte registers are used fixed part of the internal data RAM, falling in the address range 0 hex to 32 decimal, that is 20 hex. So in that manner, 8051 can save or can assign the temporary storage location of 32 byte. So this is about the register set. Register set. What about SFR? And you can see, according to the memory location, 128 bit addresses or 127 byte memory location, that is from 32 address location to 127 address location in decimal, are utilized as a stack pointer or stack area, or also the user program data, above which, that is from 128 address location to 255 address location in decimal address location, these are reserved. In no way there is no provision to access any locations. So this reserved area is called the SFR area, or it is called, stack registers, and these stack registers. So stack registers basically a stack pointer area, but this 128 to 255, the same thing. These are the reserve area which are dedicated to SFR, special function register. User cannot have access to this area. What is special function register? Or what are the names which belong to this category, special function register? That you have to understand. So what is that? From this diagram, it will be clear. What are the peripherals? Additional peripherals. Additional peripherals that can be associated with the 8051 architecture. Additional peripherals. First of all, what is the name of the peripheral? These are the internal block diagram of any typical microcontroller, almost similar to 8051, but this is general diagram. Timers counter is one of the important peripheral. Interrupt control circuit is one of the important peripheral, as well as parallel I/O ports. The registers of the parallel I/O ports are the peripherals, memory, RAM, ROM, ADC, DAC. These are also available in some microcontroller which belongs to the peripheral. So these are the peripherals which needs to be programmed and configured with the help of these internal control registers. So definitely, with respect to the 8051 microcontroller, the control registers, their names are reserved symbolically. For example, This is the area of the special function registers. The address is 80 hex to F8 hex. Now these are the fixed address location. And we can see here it is written B. That means F0 is a byte location which is dedicated, which can refer the register itself. So that means whenever the B registers is involved in program, basically the microprocessor or the microcontroller will access this area in SFR, having absolute address F0. Similarly, ACC, the accumulator, is referred as with the address of the RAM, which falls into the special function register is E0. Program status word, which holds the plus status of the status. Status means, that means what are the condition, etc. Same as the 8085. The absolute address is D0. IP stands for the instruction pointer, whose absolute address is B8. This is not utilized. P3 is the name of the third port, octal port, whose absolute address is B0. So sometimes P3 can be programmed input or output, means the microprocessor has to put either logically 1 or 0 to this location. Interrupt enable registers is another peripheral or register associated with the peripheral interrupt controller. P2 is the second port. 8051 has 4 ports: P0, P1, P2, and P3, whose absolute address basically is B0, 90, 80, etc. What is 88? There is a programmable timer. In fact, 2 timers, T0 and T1. So this timer needs to be programmed. So their absolute address, different register, falls in this range. Now, SP is a stack pointer falls to the address and absolute address 81 to the special function registers. Data pointer register DPL and DPH are the locations of the absolute address 82 and 83. PCON is another peripheral register whose absolute address is 87. So that's why basically the programming the internal peripheral means to put 10 bit stream in these absolute locations. But user need not to know this absolute address by symbolically using the proper MCS51 compiler or assembler, using the proper directive in statement, automatically this can be programmed or filled up. So this is the significance of the special function registers. This is the enlarged view. In fact, when we discuss about the programming tutorial, the concept of the special function registers will be more clear. So this special function registers is byte addressable or bit addressable. Bit addressable means individual location acts as a single bit data. For example, the P0 port is an octal port. That means it has 8 lines, which can be independently programmed as an input and output. So that's why the nomenclature is P0.1, P0.0, and P0 up to P0.7. So whenever this symbol will appear in the statement P0.0, 0.1, it means it refers to the bit addressable. That is the description of the bit addressable. So this is the software part or instruction part. Right now, we cannot understand until unless the instructions should be taught. So this is the memory organizations, internal memory organizations of 8051. That means the memory organization specifies the address, absolute address location of the program memory as well as the data memory. Now, what is how the external memory can be accessed? Otherwise, on power on resource, the microprocessor will fetch the instruction for the internal memory. That is decided by the external access pin coming out for the 8051. When the external access pin is maintained to the zero logic, the microprocessor program counter will start fetching the instruction from the external memory. Otherwise, if the EA pin is disabled, that means it is tied to the high logic 1, the normal case or situation, the microprocessor will access the instruction from the internal development. So that is actually, there is an, if we refer to the pinout description, then pinout of 51 should be again referred, can be shown. If we show the pinout description, we can see there is an EA pin, 31, EA bar. If it is maintained, if it is connected to the microprocessor will access the external program memory. The external program memory, that is how the address and the data and the control bus will be interfaced via this port line. We'll see. If this pin is normally inactive, that means disabled to the high logic, then the microprocessor will access the instruction, will access the program memory internally. So that is the significance for the EA, external access pin. This is written 31. So the functions, pin functions should be read properly. Now, what about the IO ports? Already I have discussed, there are 4 number of the IO port. So 8051 has important ports P0 to P3. These ports allow the microcontroller to connect to the outside world. The 4 ports of the 8051 microcontroller have certain specific functions and corresponding features. In that area, we have to learn the nature of the IO port. For example, the port 0 means P0 port. Each line, the architecture of each line looks like this. So this is outside, this is inside. Similarly, this is the architecture of the port 1, that is P1 port. This is the architecture of the P3 port, and this is the architecture of the P2 port and P3 port. All architectures are different. That means to some extent, all the ports have a different characteristics. For example, if we discuss the P0 port, so there are 8 number of the circuit inside it. All are associated with the port 0. All are associated with the port 0. Now, what will happen? We can see there is a mux. So, mux will be operated internally by the microprocessor. This configuration is called the totem pole configuration with a MOS transistor. One is pulled up, another is pulled down. So, this is the pin. That means for reading the data from the outside world, that means when the board is configured as an input world, this buffer is enabled, but this buffer is disabled, so that the signal can flow from here to here. But during the write operation, that means when the signal will flow from left side to right side to the external world, this buffer should be disabled and this buffer should be enabled, or D flip-flop should be enabled. So in that way, the P0 port can act as an input and the output port. This is written here. The address location, the absolute address location in the SFR area for the port 0 is 80. So port 0, it does not have the internal pull-up register. That means what is internal pull-up register? Like this. This is called the internal pull-up register. But this is called the totem pole transistor. That is, one transistor should be pulled up to the high logic, another transistor should be pulled down to the ground. So port 0 of the 8051 are the two main functions to be used as a simple input-output port, and to access external memory in conjunction with the port 2. We'll discuss later. That means whenever the microcontroller is used, or it should be interfaced with an external memory, then the port 0, the 8 line, should be used as an address lines. That is the characteristics. But otherwise, when the EA pin is inactive, that is connected to the high logic, this port 0, 8 lines will act as a separate or as a simple input-output port. Normally, upon power on reset, this port is configured as an output port. But the user program must configure with the help of the special function register to input port when 0 is put to the control register. Then the signal will flow from the external world to the microprocessor. So the port 0 as a simple IO port or to access the memory are written here. Port 1 has an absolute address of 90 in special function area or special function register area in the data RAM. The architecture of the port 1 looks like this. It is completely, this part is same, but this part is different. There is no mux. So this is for port 1. That means all 8 lines of the port 1 have this identical circuit internally. So what is the functions of the port 1? Port 1 has one DLAS, 2 unidirectional buffer, 1 FET, and 1 internal pull-up register at each pin. It has only one function. That means it can act as a simple input-output port, but it never be used for interfacing with the external memory. That is the specialty. So functions of port 1 as an IO port. It is written here. When the Power on reset, the port is configured as an output port. What is the feature of the port 2? First of all, the circuit of the port 2 is also different. It's like that. It has an internal pull-up resistor as well as mux. Combine the feature of the port 0 and the port 1. Now, what is the function of the port 2? Address location of the port 2 is 10 hex. By construction, port 2 has D-type latch, one FET, FET transistor, and internal pull-up resistors, two unidirectional buffer, and a control logic circuit. According to the functional diagram, like this. These are called the functional diagram, not the actual circuit diagram. Quite similar to port 0, the only difference here is that in port 2, we use one FET with an internal pull-up resistor instead of the FETs we saw in the port 0. Otherwise, it can be used as a simple I/O port. Now, what is the speciality of port 1? First of all, when the port 0 is unconnected to the external circuit and it is configured as an output port, this point will go to the floating point, floating level of the voltage range 2.4 volt, tri-state logic. Port 1, even though it is not connected to the external logic circuit via this pin, when it is configured to the output port, due to the existence of the internal pull-up resistor, this will go to the high logic. That is the specialty. That means port 0, normally without no connections or the open circuit condition, the logic levels will be at high logic. But here, the logic level will go to the actual high logic. Here, port 2 and the port 3 follow the same type, except port 0, which is called the open collector type port. Otherwise, all these ports are not open collector type port, as because there will be definite either low and the high logic. That is low level and the high level. But in case of an open collector, the lines, signal lines can go to the floating logic. That is of the order of 2.5 volt or 2.4 volt. So that is the specialty of the port 0. Now, eventually we will see why the floating logic is required for a microcontroller. That means for interfacing circuit may operate with a voltage, power supply voltage of different value, not 5 volt. It may operate with a 15 volt, 32 volt. So when this peripheral circuit operating at a different voltage rather than 5 volt needs to be connected or interfaced with the 8051, then open collector type port is very much preferred. Otherwise, it may damage the circuit. So we will discuss during the much more about the hardware interfacing like that. Another purpose of the port 3 is there. Some of the port lines, particularly port 3, all the lines, 8 lines, have a multifunctional feature. The port 3 can be used as a simple I/O ports, but alternatively, port 3.0 can be used for serial data communication, that is received data. Received data. Whenever we learn serial data interfacing, then this is a pin. 3.1 is used for alternatively as a transmit serial data, TXD, the functional name. 3.2 is an hardware interrupt. Hardware interrupt, that means in case of a hardware interrupt, one hardware interrupt for the 8085 is INTR. So there are two hardware interrupt signal. Interrupting circuit may generate the interrupt request signal via these pins, 3.2 and the 3.3. 3.4 and the 3.5 are used for the timer signal. T0 and the T1. There are two timers. 3.6 and the 3.7s are used for the control signal lines for external memory access. One that is 3.6 is used for write bar, writing the reading the data bytes from the external memory, read bar. These are the pin number. So the port 3 has a multifunctional pin. In fact, what is meant by the multifunctional pin? That is, from the pinout diagram, some of the pins are the dual function. For example, port 0 has a dual function. It can be used as a simple input-output mode, as well as it can be used for the address data, low-level address data interfacing, 8 lines within bracket. Port 3 has a multifunctional feature. It can be used as a simple input-output, as well as it can be used for other functions, RxD, TxD, IN T0 bar, IN T1 bar, T0, T1, etc. Write bar, read bar, these 8 lines. Port 2 is of multifunctional nature, means it can be used as a simple input-output logic, as well as within bracket, it can be used for higher address bytes, designated as A8 to A15. But the port 0 are used lower address byte, AD0 to AD7. So the 16 address lines are available to access the 64 kilobyte external address space. At the same time, and another machine cycles or time cycle, this lower order address bytes be configured as a data access, designated as D0 to D7. That means it follows the architecture of the 8085. Why? 8085 uses address data multiplexing feature externally. The same thing. That means these lines should be multiplexed with the external circuit. What is that circuit? Address data multiplexing circuit. This kind of circuit this is the circuit. Functional diagram. So external program memory of 64 kilobytes can be connected like this. So the 16 lines which are available for this memory size, 64 kilobytes, should be connected to the 8051 externally, one via latch, another directly connected from the P2 port. So ALE signal is also available from 8051, which will latch the store the lower order address bytes to the latch, and it will remain, so that these bus can be used interfaced with the 8 lines from the data memory or data lines from the memory. So these combines here as AD0 to AD7. So this is the interfacing diagram how the external memory can be interfaced to 8051. Now, this is of which type of memory? Size is 64 kilobyte. But if it is required to design an interfacing circuit with 32 kilobyte memory space, which is partitioned or split into 16 kilobytes and the 16 kilobyte, then definitely there must be a decoding logic and other things. So I will give you the different memory interfacing problem so that you can design. Otherwise, this is a basic functional. So try to understand the philosophy of the memory interfacing, or very important part. Otherwise, you cannot apply the microcontroller to the application circuit. So this part is taken from the textbook Majidi and Malidi 8051 IO port programming. Only this chapter. I think this book, total book, ebook has been sent already. You confirm whether it is true or not. So how the program can be developed by involving IO. So these are the segments. But you must need to know the instruction format or assembly language programming for 8051. So in next class, I will, in fact, the instruction should be must be known, and the instruction you must learn, and that means reading simultaneously the peripheral and the instructions or assembly language program will give you the insight to develop the total program. Okay, so next class, I think there was a loss of classes, few loss of classes. So in each week, I will take the class from 6 p.m. Is it okay, 6 p.m.? The timing for the every week, that is 6 p.m. Today I have started the class taking from 6:30, but it should start from 6 p.m. Is it okay? Or it may overlap to the other class?
Yes, sir, it is okay.
Okay, so from next week, I will take the class from 6 p.m. So it will be, I think, convenient for you whether I will take the class for 1 hour or 2 hours or whatever may be. Because so many concepts are required. First of all, you have to read the theory of internal architecture, its peripheral, then the programming part and interfacing part. So today, I think there was a discussion on reset circuit, oscillator circuit, interfacing, and the IO architecture. This 4 part. Not IO programming, architecture of the IO. So today I am ending. So let us meet on next Tuesday at 6 p.m. Thank you.